Okay, this is the TC workshop. I know you all want to be here. That's why you're here, right? Okay. And this is Dev Tat. He's going to play a song at the end.
I might.
Yeah. So the agenda is, there's really no formal agenda. I just made this up like 15 minutes ago. We want to talk about, so we're deprecating, I just want to see who uses TC. Are you here just for the tour or you use it? All right, thank you. Thank you. So we are in the process of deprecating some QDisc filters, actions, mostly because they are just a source of all kinds of syscaller bugs. So we've killed 3. I think it's those 3 that we killed. CBQ, QDisc, anybody uses CBQ? Nobody? We've killed the TC index classifier. Anybody who's big on that? It was used mostly for diffserv, long-lived diffserv. RSVP as a classifier is gone. Did we kill DSMark, or is still around? I think we're targeting DSMark next, which is a diffserv legacy QDisc. We deleted, right? So I think for the whole network subsystem, we're the only heroes that have done this. I don't think there's any other subset of who else has done this. Damn. Oh, but you did it after we did it. After we did ours, I think. You did it after. IPX. I know DECnet is recent. So what happens in the case of IP Route 2? I mean, since we got both maintainers here. Someone give a mic to because I don't think people remote can hear him.
So basically, if you drop it in the kernel,
Yeah.
I'll drop it in the user space version. So if 6.8 drops support for RSVP in the kernel user space, it'll go.
Okay, so it's gone. Maybe we'll send you a list of the ones that have been dropped. I think you'll find it pretty quick. You do copy the URP headers, right?
Right.
They're gone.
But no, a lot of times you have to leave those around for stupid other reasons.
Okay.
Okay, so the URP you leave on, but the code you just remove.
Yeah, so he's going to remove it, he said. Right, you don't need us to send any patches? Okay, excellent. Anybody hates something, a QDisc that they think it's not being used? Any suggestions, please, maybe not here, but send us email. Send me email. And I got Kong also, who's a maintainer here. I think Yuri is probably connected remotely. Just send us a list of things you don't think are being used, and we'll be more than happy to delete them. Right? It's time. Like CBQ has been around since kernel 1.3 something. It was the greatest QDisc ever.
Just because you wrote it.
No, I didn't write it actually. Alexei Kuznetsov wrote it, but it's been good to know CBQ.
You should have a policy around it and a deprecation period, though, and not just an instant removal.
Man, that thing had so many syscaller bugs. It's like every morning I wake up and there's something, and I'm going, shit, I had other plans today. Right. So, but we'll be kind to the next ones. Okay, so that's test. That's number 1. Number 2, this session was supposed to be about testing mostly. Testing plus DevTat. Everybody DevTat right here. And we're going to miss one of those presentations, actually. So we've been doing a lot of testing, and we really would appreciate anybody sending patches to also submit TDC tests. Sometimes the patches are applied before we see them, but it would be highly appreciated if, as part of your commit, your patch number 2 includes a test, even if it's a bug fix.
Patches don't get applied quickly, so.
Yeah.
Sometimes I am on a plane, and by the time I land, they're applied, right?
I
don't know how to fix that.
Not IP Route 2 side.
Not IP Route 2 side. You're right. Yeah.
May I make a feature request?
Yes, sir.
Running a single iPerf for 1 minute is really not a particularly good test of a network driver. I'm going to burn a slide in my talk, but if you can run more robust tests for longer, days preferably, you will find all sorts of wonderful bugs. Most recently, we tested a whole bunch of ARM64 platforms, and over half had problems running for more than a few seconds.
All right, so we're going to go through something called Tax Suite. Anybody's heard of this? It's a fantastic test CI/CD environment, and we recently added support for TDC. So Vishal is going to spend about 15 minutes going over it. Pedro is going to go over. So on P4TC, we have like 400, maybe 500 test cases for TDC, and they were taking forever. And so what we ended up doing is parallel. Pedro spent a bunch of time making them run in parallel as long as they don't have any dependencies. So now we can finish, a few hundred tests. He's going to present. We've been trying to do a lot of performance testing in terms of, from the control perspective, and this is mostly driven by P4TC. However, the Flower guys also had a test. I think Vlad, I don't know if Vlad is online or not. How fast can you add entries into the kernel? And this is a big deal, especially if you're trying to offload. But even for software, if you're running like Kubernetes workloads where the container can't start up or the pod doesn't start up unless you've completed your addition of the rules, then the speed at which you can add rules is extremely important. So we're doing some of these numbers, and also we are doing them, to be honest, to get some bragging numbers, so numbers we can brag about. There is, again, this is a few of these things because I'm just waking up and seeing we really need this. You know how it works in the kernel or in Linux community in general. You need something, that's when things start popping up. So we needed to be able to add a high number of permutations of test cases for the data path, not necessarily performance. So now this works well for P4TC because you start with the P4 program and then we can generate like 500 test cases. The compiler does all that for you. You don't have to actually hand code them. At the moment, our testing is hand coded, but in the future, the compiler will generate. Unfortunately, I don't think the speaker for that last bullet is going to show up. And of course, to finalize this session, Mr. Dev Tat, everybody. The king of buffer float, the slayer of buffer float is here with us. Okay, so it's going to be the last session. All right, so to start, Vishal,
hello, everyone. This presentation would be around testing, as Jamal was saying. We want to make it easier for all the developers to test their code and submit it upstream. I'm Vishal. I work with the TuxBit team in Linaro, and I have Anders with me, who's the maintainer of Linux kernel functional testing in Linaro. You can go to the next one. So TuxBit is a cloud-based platform developed by Linaro. It also provides a few open source tools which are built using containers to make it easier for the developers to build their code and test it on different architectures without worrying about the build dependencies and test dependencies while they are actually trying to run them. I'll try to keep it fast and skip a few things so that we can go through this. Yeah, maybe to the next slide. Yeah, TuxBit, in terms of its capability, it can build many things, but I will mainly talk about the Linux kernel stuff. We can build Linux kernel with our open source tool called TuxMake. TuxMake is a Python library which itself has a CLI as well, which is built on container runtimes. It provides more than 100 different containers which package different toolchains from GCC 8 to the latest GCC toolchain, as well as from Clang 10 to the latest Clang nightly toolchain as well. You can use TuxMake with a single command. You will be able to build the kernel tree for whichever architecture you wish to without having to install any build dependency yourself. And the same tool is run in the cloud for you with Tux Suite. On testing side, we provide a tool called TuxRun. It's again a Python-based application, which again is using container technologies to run your test cases, boot testing your kernel that you've built, as well as running other test suites, which we've mentioned on QEMU as well as ARM FVP models. We also have support for real hardwares in our lab on which you will be able to run these test cases and easily integrate any new devices that you wish to add to the system. And we put a lot of effort in curating the root FSs needed to actually run these kernels against with all the latest test suites, as well as we update all the dependencies for those test suites as well in this root FS, so that developers can just concentrate on developing their code and not bother on what are the dependencies that you need to install to run these tests. And also kind of constantly keep updating QEMU in our containers so that you can always choose which QEMU version you want to run these tests against, or the latest as well. To run these things in the cloud, we have a file called plan file where we describe all the different kind of builds, whether you want to build it against x86, ARM64, or all these targets which you want. You can specify them. It's a descriptor YAML file, and then you can specify the tests which you wish to run. And with a single command, you'll be able to run maybe around 500 builds and corresponding tests in the cloud for you, or even in the hardware, and get tag results. We have other tool called Tux Trigger, which can remotely directly monitor your kernel tree. You just need to configure which plan file it has to test against, and whenever you push patches to that kernel tree, the system itself will run all this builds and test and send back the report to you. So to interact with this cloud API, we have a Tux Suite CLI with which you can interact. Yeah, next slide, please. Yeah, I'll hand it over to Anders to quickly go through each of these examples with Tux Suite CLI. Anders?
Yep. Can you hear me?
You're a little muted. Maybe get closer to the mic or something.
Yep. I'll try to speak up. Is it better?
A little bit. We can hear
Well,
you. Yeah. Go ahead, please.
let's cool. Hey, my name is Anders. I'm gonna take over now and talk about how we can build this from the command line. And I just want to highlight a few things. How we can build a kernel. We say Tux Suite build, and then the kernel tree, the branch, target architecture, tool chain, and make variables, and then def config or configuration files added onto that one. And you see at the K config, we have the path to TC testing config. And then we want to build headers, debug kernel, and modules and K self-test. Next slide, please. That will build the kernel. And then to test this kernel, we can run similar command, but we say test, and we say device QEMU x06. We add build kernel artifact storage and point to BZ image and the modules, and then also we add a parameter flag to add the K self-test tarball, and we can say TC testing for the test suite, and we can tweak the timeout as well. And this is well and good. And next slide, please. It's a bit cumbersome to have to do this. Hello?
Yeah, is that the slide you want, or? Hello?
Yep, hello. If you're on the plan file, yes.
I can't make out what you're saying, Anders. Can you repeat that? Anders?
Hello?
Yeah, what, did you want to stay on this slide or move it to the next?
Yeah, I think he's having some
Sure.
network issues. Let me just take it over from here.
Okay.
Yeah. So with the build and test being done separately, you generally build the kernel and then run the test. So that's where we introduce a plan file where you can describe both builds and test. Yeah, next slide, please. Yeah, this is part of our plan file, which is descriptive YAML, where we have the metadata and we describe the build that, yeah, use the Clang Nightly toolchain and build it for x86 architecture and the make variables and the kconfigs that you need to do. Next slide, please. And here we are describing the second part is once the kernel is built, you then run this test on QE x86 with the specific rootfs, which is what we curate, and publish, which are always up to date, and users don't have to, basically developers don't have to bother about all this stuff. And so, yeah, next slide, please. Yeah, you can see this is just a GIF which I've. So now you can see the Tux Suite plan. You submit the plan file, and the system executes it in the cloud for you, where initially it is doing the build, and then it is actually running the tests, and eventually completes it within 30 minutes. Unfortunately, I have just sped this up for demonstration here. Yeah, next slide, please. I'll go through the artifacts. So this is the web page, how it would look once you've done the build. And once you click on the interface, you will get the details on which plan you've run, which is like building kernel and the KSL test and running it with Clang Nightly toolchain and KSL test, TC testing. If you see the details, it will show that the build actually passed, but the test itself actually failed. Next slide, please. Okay, and this is the interface we have. If you click the build ID, you would get the details of the build itself. Yeah, it'll show what config went in and stuff, all of these stuff. And yeah, we have errors mentioned because it was trying to compile the complete KSL test. But overall, yeah, it is marked as passed. Yeah, next slide, please. So this is the test result page where it will show the duration. And since it is showing that build has failed, you can then maybe click the logs HTML link, and it will show you the complete logs of the execution and where it has actually failed. The interesting part which I want to talk about are the reproducers. We provide two scripts. One is a local reproducer, which the developer can share it on the mailing list, and users can use it to reproduce the issue locally. So Tux Suite is designed in such a way that it should be easily reproduced so that you can share the errors itself. And the only dependency for the other developer is installing our Tux Run and the tool and the container runtime like Podman or Docker. Yeah, next slide, please. So this is how the local reproducer would be for the build, where eventually you're calling tux make build command, and you specify the config that was generated, and it will reproduce the same kernel. If it is a build failure, it will be reproduced for you locally. Yeah, next slide, please. Similarly, we have the local test reproducer, which will be using the Tux Run tool, and here it's using the Podman runtime. You can as well use Docker if you have it on your host. And it will run the test by using the Cameo version, which is tied up with our Tux Run tool itself, and you'll get exactly the same error. So sharing your errors for reproducibility is very easy with the tool. Next slide, please. Yeah, so the tool itself has a lot of features. I've tried covering a few of them. So here, if you want to submit your plan with certain set of patches that you're working locally, you can specify the upstream kernel tree, which is next here, and the mbox file for that patch series, or a local directory or a tarball of patches. The tool itself will upload your patches to the cloud and apply them on the next kernel tree, and then build it and run the test for you and does the validation for you. This is one way you can use to validate your stuff before pushing it for review. And as Jamal was saying, you can have your test results here. Next slide, please. Yeah, the presentation here and the plan file. The idea here is that we will have curated plan files which you can use for your network testing or some other testing as well, based on whichever section, whichever part of the kernel you're working on. All the resources are uploaded in that GitLab URL. People can try it out. We have a plan file which does the build and test for x86 as well as ARM64, along with Clang Nightly and Clang 17 toolchain. There are other links for the other open source tools that we provide. One of the interesting things is the dashboard visualization. I don't have time, but this is where our trigger project comes into picture, where whenever you push updates to your kernel tree, it will do the builds and show you historic results as well. If anything is regressing as such, there is documentation for you guys to check. We are issuing tokens for upstream development. Please sign up on that URL, tuxsuite.com. There are actually two boxes. There's one at the end for beta users. Please use that, or just email us at tuxsuite@linaro.org and we'll issue the token for you. Yeah, everybody's welcome to use this tool. Thank you. I think that's it.
Thanks, Vishal and Anders. Any questions? Anybody using this out there? Nobody? You've never heard of it before? We found it to be extremely useful. Finally, we don't need the Intel robot to catch our bugs, our GCC 11 or 12 compilation. So we internally use it for, I think, I don't know how many compilers we test, maybe 6, 7 different compiler versions from Clang to GCC 11, 12. We do the patch by patch testing with this. What else do we do with it? TDC testing. Yeah, and of course the TDC testing. But the nice thing is the Linaro guys do run this by, I believe, if I'm not mistaken, Vishal or Anders, you would pick every new branch that comes up or new, and you test that as well?
Yes.
Right?
Yes, we do RC testing on the master and next branch as well as on the stable kernel.
Yeah, so I think what this would have been really nice, let's say, to pick up patches from Netdev mailing list maybe, and just run them every time they get posted there. I don't think patch
Yes,
suite
that would be possible.
Yeah.
Yeah.
Is that possible, you think?
Yes, that's possible. We will look at setting up our monitoring on that mailing list as well.
Yeah, the other thing we do is syscaller testing in our setup. I guess that's too much CPU cycles to be asking for. Are you thinking about running syscaller as well, maybe?
Anders, can you comment on that? I will take this as input. I will check with the teams whether that test is also being worked on enabling it.
Okay. There's a question. If someone can pass the mic. Where's the mic? David, you have the mic, I think.
For the testing, is it mostly K-self tests, or can we plug in our own test suite and say also run these tests after the kernel build?
Currently, we have support for K-self tests, LTP, perf, libgpiod, and all this stuff. We can work with. We are cautious on just enabling users to run anything and everything. So we can work with you in adding your test case, validating, and then adding it. As I said, we enable these cases which are like curated ones, which we guarantee that they run so that it works well with all the users. We can work on adding any specific test suite that
Pass the mic.
is of your interest.
David. Sorry, man. You're sitting in the front. This is what happens. Yeah.
Vishal, do you have a plan to integrate it with Patchwork to post test results to Patchwork?
Yeah.
Anders, do you want to comment on that? Currently, we do monitor the list, but I don't think we've done the integration as of now. But I'll take it as an input to investigate.
No, we have not done the integration as of now. Sorry for the short breakage here. But we can look into that.
Yeah, I think would be a great next step. I saw Jakub saying he doesn't want people to just be randomly sending patches so Patchwork can test them. But we could add it to this, right? It would be a great idea if you can. I know you're banning CPU cycles. I don't know who's paying for that, but it's a great service to the community. We run it on our own internal machines right now, and we're very happy. You can tie it to GitHub and all that kind of stuff. Okay, if there's no questions, we'll go to the next one. Pedro, I think you're next.
Yeah.
Okay,
hi, Jamal.
sorry, there's somebody asking a question. Yeah?
Yeah, we do have a question from the remote attendees. Can I read them?
I'm sorry, say that again?
It's Leo. It's Leo here. We have a question from remote attendees.
I can't see anything. Can we, Carl, can we have the remote, can you turn on the chat as well so we can see? Okay. The question is from Marcelo. Oh, Marcelo is hiding out there, okay. Does it support cross-compiling testing maybe with QEMU emulation?
Yes, it does.
It does. I'm very impressed by this tool. I'm happy with it. More questions in the back there? Mike, maybe we need another mic, Carl, if you have another one, so we can put one in the middle.
I saw that you guys support S390. How do you deal with performance? Because I assume you're using IBM Open Cloud.
What performance are you talking about?
Just compiling on those machines are pretty slow.
No, we don't compile on the S390, but we do cross compilation for that architecture.
But you're using their machines, right? I assume.
We do it on the Intel machines.
QEMU?
Oh, you use QEMU. Got it.
Yeah.
Thank you.
Okay. All right, I think we're going to wrap it up here. We're doing well on time because one of the presenters is not going to show up today. I'm going to hand it over to Pedro next.
All right, so today I'm going to talk about the parallel TDC work that we did, which is upstream already. So TDC is the TC testing suite. It has been for a long time. And as you guys probably know, there are thousands of test cases over there. It's still growing. When P4TC gets in, it's going to add a lot more test cases. So we have noticed that a lot of people have been complaining that it takes a long time to run the entire test suite, especially if you're building with debug configurations. And mostly because it uses a lot of fork behind the scenes. And it's calling IP route 2 directly most of the time. So as you guys can imagine, you keep spawning processes every time, so it gets quite slow. TDC is also integrated in K-self tests, so it has been running by public and private CI services for a long time. And it was time to take care of it. It's somewhat self-contained Python code. It doesn't have any external dependencies, so it's pretty portable in that sense. The real external dependency is Scapy, but that doesn't seem to be an issue. Most of the root FSs out there, they seem to include SCAPI already. And it was a painfully serial program. We had all these test cases. They could run in parallel, but we are not doing anything with the other cores. And that begged the question why we are not using the spare cores. So the idea was to transform every test definition that we're using net namespaces as a self-contained unit. So once we get there, we can run all these tests that are in net namespaces in parallel. And the main motto is that no tests should interfere with each other. We didn't have any example of this in the tree, but now it's kind of set in stone. You cannot really do like tests that interfere with each other anymore. And the idea is that we would split the test suite into 3 phases. The first phase would set up all resources. This was actually something that improved our work queue and RCU interactions. And then we would run all tests. Some tests, they had to be run serial in regards to itself, but most of the tests we could run in parallel without much trouble. And then we would report the results. So we have been using Python libraries all the way. So we are running over a worker pool. And if you want to check it out, how to run in parallel, you just use the -J argument. And even though most of the tests, they serialize over RTNL, we got a total runtime drop of close to 2.5x. So that was a pretty good speed up compared to what we had before. Next one.
That's it, right?
No, next one. Yeah. So yeah, so we still have some work to do. We did a lot of changes in the code base, so there are still some rough edges to improve on the CI services. I mean, I'm in contact with the Tuxedo guys. We are not really getting the green there, but we're gonna get there soon, I hope. And I also would like to let the bowls run, quote unquote, because KSelf-Test by itself, it's not running the entire test suite. We had a lot of unstable tests in the filter section, which is the one that has the most tests. But after these patches went in, I did a lot of cleanups there. So I think they should be good by now. And also, we're still having some issues with RCU and work queue. I mean, it's the classic, it works on my laptop, but it doesn't work on another guy's laptop. So, I mean, obviously the easy workaround is to just put sleeps everywhere, but that's not that great either. So we are trying to brainstorm a way to catch these sort of issues and try to make it perhaps event-driven. And then we also need to improve our resource setup time. I've seen that it takes a little bit while on debug configurations to bring up all the net namespaces and all the net devices that we need. So one idea is to just call netlink directly, but I mean, it's kind of an issue to re-implement things. And I don't know if it's going to be like a good thing to bring in another Python library or something into TDC. So it's something that we are also pondering. Okay, so that's it for my presentation. I hope if someone has any idea to improve things on the TDC land, I'm open to new ideas as well. And most of the changes that I talked to you, they are already landing on the next version. And hopefully by the next merge window, I'm going to try to send more patches to fix these shortcomings that we had.
Questions?
Any questions?
Okay. Do people know what TDC is? Who knows what TDC is? I'm going to ask the positive question. Okay, there's 2 people. Okay. Well, this is how we test We try to make sure nothing breaks when somebody makes patches in TC. We're still
The control plane level.
yeah, the control plane. It's user space. It's IP route 2 based. Yeah, things do break. Sometimes patches get applied and they break things, and then 2 weeks later somebody's complaining. But so we're trying our best. Please, if you're submitting any TC patches, make sure you at least write a test case or two, right? It helps you as well if you're maintaining that code. Okay, and thanks, Pedro. Oh, who has a question? Okay, Mike, please. Carl, do we have two mics or one? Okay, there's one in the middle. Maybe put one in the right here, and yeah, just drop it by somebody in the middle. They'll pass it on. Go ahead.
So I didn't know what TDC was, but if it's a collection of case self-tests, are you able to run it inside of Tux Suite from the previous?
Yes.
Okay.
Yeah, it's integrated, so shouldn't be any issues. And I've been in contact with the Tuxedo guys. We had some issues there. They are not really passing right now because of these changes that we did. But hopefully we're gonna get them working.
Okay. Yeah, we use TuxMake heavily. TuxMake. Thank you to the Linaro people.
Any more questions? All right.
We actually had our own, but we killed it. Yeah.
So I'm going to present to you guys about what we did for P4TC control plane performance testing and also some concurrency testing. So our motivation was basically the following. In P4TC, we had a hard requirement, which was adding, CRUD operations with table entries should be as fast as possible. And to achieve that, we tried to make the code as lockless as possible and as concurrency friendly as we could. And that, of course, you did some, we reviewed the tests, the C files, etc., to see if there were any concurrency bugs, but we thought, since this code is quite big, there will be a lot of bugs hidden there that we haven't found. So we wanted to create a tool that we could do these concurrency tests automatically also, and like as much threads as possible, exercising, creates in parallel to deletes, updates, etc., all that nice stuff. And so to do that, we created a Rust program, basically, that does these things for us. I'll show you guys a simple test case of how we implement it. So what I'm showing you guys is a test case that caught a bug that we had in our code, which was the following. We tried to add a lot of table entries in parallel threads. And something important to say also is that in P4 specifically, when you create a table, you need to specify the maximum number of entries that you can have in that table. And the problem that we found was that in specific concurrency scenarios, we were able to add more tables than the allowed, right? And so we created a test case to try and do this, to try and reproduce this issue automatically, like in a CI/CD or something like that. And this test case, this is an implementation of a test case. So when we try to create these test cases in Rust, we have 5 methods that we need to implement, which is the first one is a create, which is basically like an instantiation in object-oriented languages. You can think of it like that. There's the name method, which is, just tells you the name of the test case. There's the run, which does the meet. It will add all of the, in this case, table entries in parallel. For you in various threads. And then the verify method will, after you run it, it will see, in this case, if you added the right amount of entries, if you didn't exceed this maximum. And then the report one is also an important one, which is it reports the benchmark numbers. So one thing I didn't say is that this is also very, we use it a lot to do some performance testing to get the control plane performance numbers, etc. So this report callback here will just tell us what the numbers are. So I have some preliminary benchmark numbers for you guys. So we ran on an AMD Ryzen 4800H in a QEMU environment. So the preliminary numbers we have here is that for an exact table, we could add 641,000 entries per thread. When we try to do an exact table entries but with an action bound to it, it fell a bit to 463,000 entries per thread. We also have a batched feature in P4TC where we can send at max, we can increase this number, but at max as of now 16 per batch. So with that, we increase it a bit without the action bound to it to 659,000 entries per thread per second. And when we tried to batch it with the action binding, it was 657,000 entries per thread per second, and in this case, 16 entries per batch. One interesting thing also that this tool enabled us to do was catch performance regressions. So in this case, when we rebased on NetNext, I think in September, I don't remember exactly the date, we caught a performance issue that the numbers basically went down by half. We, like Pedro, looked a lot at it. We took a while to find out what it was, but it was basically an AMD vulnerability mitigation, like a branch prediction one, SRSO specifically. And yeah, once we figured that out, it took a while, but once we figured that out, we removed this mitigation and the numbers went back to normal. But yeah, just to emphasize, one of the things we wanted to do with this thing is have, like, you push something to Git, it runs automatically the performance tests, it catches any regressions, and then it will send an email or something to us saying, oh, the numbers went down by half or something like that. And yeah, we thought that would be very useful for us. And basically, that's all I have. Any questions?
Did you bring that up to the AMD folks? Like there are options. I would assume other things are going to be penalized by that as well.
Yeah, definitely. Okay, yeah. So since this was running on a VM, we thought perhaps it could be QEMU itself not getting the proper updates for this mitigation. But yeah, it was something that caught our eyes, and it was really hard to debug because not even perf was showing nothing. We had like to kind of, okay, let's try to brainstorm what is going on. And then, yeah, I don't know, if you know someone at AMD, perhaps we can talk to them. But yeah, we didn't bring that up to them yet.
We should be able to test it on bare metal, see if that is not QEMU, but it's very recent.
Makes me
right?
nervous updating kernels on AMD platforms.
Yeah, you may see this. This is just like, what, 2 weeks ago, and we were kind of panicking because we had changed some code, so we thought it was our code, and we spent like a whole day auditing our code.
Any other questions? Yeah, I think that's it.
All right. Yeah, Carl. During these sort of breaks, maybe you can patch up the remote people as well, like on the screen. Like maybe there's somebody remote that has a question. We're still learning this hybrid thing. Yes. Are they? Yeah. Yes. Anybody remote has a question? No. Okay. It was crystal clear. You know the joke, right? Okay. Now, the slayer of Bufferblot, the man, king of the road. I don't know what else to say there. Like, I'd like to play some music.
Shazam! All right, who here has already heard of Bufferblot? Say, raise your hands. 14 years of work to share this one word with y'all. I have had a habit of going to every conference I could and trying to blow up the Wi-Fi, particularly during things like Toki's talks. And this was the first time that I have ever managed to do this without blowing up Toki's talk. So Toki, you did come through loud and clearly today. Give us a yay for Toki's work, everybody. Yay! All right. My opening slide here is a test called the Flint Rule Test. It's the most brutal networking test that Toki and I could devise 10 years ago. And how many of you people run it regularly? 3. Honestly, you can use a simple testing tool to be able to compare multiple things over multiple times across multiple variables for a really, really long time and be able to figure out all kinds of really interesting problems. If I could just get one more person in the room to run this regularly in their test suite, I'd be a really happy guy. Any volunteers? Yay! All right, we got one. Let's move on. So, who here runs FQCoddle? How many people do you know? 1, 2, 3. All right, everybody in the room, running Linux and Windows WSL, run that command. Right now, I'm going to sit here and wait. Wake up, type in that command. I don't see anybody typing it in. Come on. How many here are running apples? Raise your hands. Okay, netstat minus I en0 dash QQ. Okay, of those of you that have managed to get past the lack of coffee and type in these commands, how many of you actually were running fqctl? That's on an Apple over there, sir? Okay, Linux VM. My larger point is that this is a simple, beautiful, single algorithm that now manages most of the packets of the world. And it does so well that you never noticed until today. It has some really neat features that are underused, and I'm not really going to talk about them. But who here has heard of Cake? Yay, same damn 4 people. But basically, Coddle had a few problems. It was less than perfect, so we spent 5 years perfecting Cake, making sure that we could possibly replace fqctl with that just as universally as we did with fqctl, which replaces FIFOs. FIFOs must die. Anyway, Cake is right there in most Linux distributions. It's used by a lot of stuff. It's one line of code, and it makes your internet consistently better. I'm really big on having people do tests. Who here has ever run a buffer bloat test? Okay, I got some significant number more of you. There at the bottom there is the best test. Go to your hotel room, go to a cafe, go to a cyber cafe, do it right now and right here. And watch your network go boom. Watch so many networks go boom. And the thing is that the buffer bloat test is something that just exposes something that happens to our network every darn day. Every single time you do a big download, your network does this to you. And it's one of those bugs that's so subtle, it has changed humanity. We have all learned that as soon as you do an upload, it's time to take a coffee break. Never, ever do an upload while on a Zoom call because they won't be able to hear you. And so long as that we can find some focus, and all the way up to the government level, we can actually make this portion of the internet silently better for a really long time. 14 years at this, though. The thing is that the deployment on all this stuff is on the precipice of being done. Okay? Now, there's a different AQM algorithm in all the DOCSIS 3.1 modems in the world, which is like well over 80 million. Only Comcast turned it on during COVID. This is one of those moments where I would love to know some publicly spirited hacker that could go into the other cable modems of the world and somehow add one line, just one, AQM 1. And 100 million people would have a better upload experience all the time. I learned something along the way about how ISPs sell plans. They don't really care about many other things, and that's why I'm doing what I'm doing now. I'll get to that in a minute. And everything's based on OpenWRT, 10-year-old versions of it. So I'm hoping very much that somehow, you know how we just obsoleted CLS? It's going to be 10 years before it vanishes from the field, you know, or more at this rate. Anyway, we upstreamed Cake back in 2018 after 5 years worth of development that only 6 of you have heard of. And it finally saw some commercial uptake in the MikroTik release, which managed to spread out all over the place about 2 years ago. And it proved that we had some other problems. It took, 5 years to hit deployment and start getting bug reports back. And I am being deliberately contrarian. All of you are spending all this massive, wonderful, amazing time bypassing the stack. And in the home router market, you got to care about all these other things. And that's why we put them in the damn kernel in the first place. Okay, firewalling, being able to do packet captures, packet counts, all these other weird things we do are actually really, really necessary. And you can't replace it all with eBPF. I would like us to be trying really hard to be finding ways of speeding up the native kernel facilities. One of my bugaboos is we have NAPI 64, which is a number that we picked out of thin air in 2003 before we even had multi-cores. I don't even know who remembers where that number comes from. Do you remember?
It was a good number.
Okay. Now, most recently, so we looked at the deployment. Everyone was complaining about the ARM64s and this technology that was really crucial to the effort. Don't get up yet, Tom. Effort, BQL had not made it into half of the ARM64s that we've seen. And the RISC-64 that we tried was miserable. So as much as I think working on KMQ would help, you're all wrong. Please, please, we need to work harder on the basic kernel facilities like TC in order to be able to enable the future. So my first lowest level thing is this amazing technology. It's called byte queue limits. This amazing technology allowed modern fair queuing and AQM technologies to actually work after being broken for 20 years without people understanding what they are. And I would like everyone to give Tom Herbert a bit of applause, please. Six lines of code extra per driver. Cut an order and a half of magnitude off the latency and jitter, or more, off of all the network cards we had in the world at the time. I think it's in over 140 baseline drivers, but the embedded world, lots of places forgot it. And if I could somehow get the kernel community to refocus on BQL, it would be great. The thing is that as we've been working on deploying this stuff, BQL is beginning to fail to scale. And I wanted Tom to tell me if he's ever had any thoughts about maybe getting away from what's called MIAD, or maybe using cross CPU locks in order to handle the multiple cores that we have. I don't know, but right now I'm seeing hundreds or dozens of queues with a fixed amount of latency per CPU, and it makes me nuts. Tom.
Yeah, the first thing about BQL, I go back and look at that code. I can't believe I ever wrote it or understood it. It's some interesting code. Yeah, we should have this discussion. I haven't actually looked at this in a while. The one thing I would point out, so a lot of what you said, Dave, seemed to be more of a deployment issue than actually implementation, right? We need people to enable stuff by default.
It's half deployment and half how the market has changed. We have many, many cores now. We can take atomic locks faster. And so looking at both those things at the same time is on my mind.
So the one thing about BQL that I've always advocated, and I think you might not have been completely in line with this, but to me it should be just something you put in and it just works.
And it does.
Never ever have to configure it. So it got a little worrisome when people were trying to add little hooks. Because if you think about it, okay, so somebody in this room, sure, they can optimize through configuration. The rest of the billion or so users on the planet, no way. So getting to that level where this stuff just works automatically is good. Yeah, we always knew about the scaling of BQL and with multi-threading, that's definitely sure. And yeah, getting rid of CPU locks is a good idea. Actually have some ideas about that, which is a little bit separate. We could have a discussion on. And yeah, so MIAD I'm not actually familiar with. What does that stand for?
You have multiple increase, additive, decrease. AMD is how TCP works.
Oh, okay.
So I had a theoretical objection to that strategy going back in the very beginning in the sands of time. So I think it's possible for it to drain faster than it does.
Yeah. Okay. So yeah, let's take a look at it. It's
cool.
Like I said, it's an interesting technology, but it's good to see it still popping up as useful. What do you mean many ARM64s missed it, by the way?
We did a survey recently of some of the latest ARM64 products, and they'd all forgot to put in the 6 lines of code to enable BQL.
How did they miss it? They just didn't enable it, or
they just forgot. Nobody pressed them on the issue, or the code was out of tree and they shipped that. So and the results were horrible.
Yeah, that's not good.
NVIDIA, for example, had a product whose Ethernet card worked for about 10 seconds. Must have passed all their tests, but basically it just crashed. I have a 190-page document of all the ARM64s we tested. I can pass around. So it will be my hope through source code inspection and chasing after people, or maybe a Cosnell thing, we could go nag people to add it into this and future network drivers. It's a great thing, and the API is beautiful, but it needs to be in the embedded market more than anywhere else today.
Okay.
Cool. All right. I have more time than I expected. Thank you, Tom. Everyone give Tom an applause. 12 years worth of work. Ubiquitous, simple, and you're right. Nobody cared or noticed.
You wrote the book on buffer bloat, right?
Toki did, actually.
I just want to know how much Tom paid you for this.
But nobody knows. Honestly, Tom made this fundamental breakthrough that made 20 years worth of academic research actually work. And nobody had noticed before he got involved. It's amazing. So another fellow that I really admire is not here today is Eric Dumasay. Can everyone give him a hand? Linux Network Ninja. The guy belongs, in my opinion, in the Internet Hall of Fame for all the amazing things that he's invented. And I am actually going to ask that all of us here submit him for the Internet Hall of Fame this year. He's very reticent. He's very quiet. He's one of the most. He's like Kelly Johnson. He can see nanoseconds in packets. Anyway, he invented this concept called flow queuing, which is actually a first major innovation on top of fair queuing. And at the time, none of us really understood the power of it. And yet, this idea has seeped into all of Linux and in almost all of our design since. So I finally, after 10 years of trying, came up with a really simple way of describing it versus fair queuing. So I'm going to read it out here. If the arrival rate of a flow is less than the departure rate of all the other flows, and it's well paced, it goes out first. Otherwise, it is mixed more or less evenly with all the other flows. Now, if you read about fair queuing and round-robin service times, it's that second sentence that's what happens here. But this is something that recognizes that the arrival rate of a VoIP flow is like one packet every 20 milliseconds. And it's never going to get bigger. And that means it will almost always go out first. Toki did a really good but too obscure paper on this called Understanding the Latency of Sparse Flows before we had a name for flow queuing. And this is and somehow, almost over the last decade, injecting this behavior into most of the internet. We've established a reward system for applications to use slightly less than their fair share of the bandwidth. And if they do that, they experience zero queuing. We're still in a world out there where you see seconds or tens of seconds of queuing out there under load. We could get down to zero for all VoIP and video conferencing and gaming traffic over time with the magnificence of this one idea of the hundreds that Eric Dumasay has had. QoS is mostly no longer needed so long as this behavior makes it into more of the internet.
I'm not sure I'm buying that, but...
Well, I'm trying to get people excited, but I partially agree with you, all right? But my point is that if flow queuing becomes the default, we have a lot more options than we've ever had. Will you agree with me on that?
Okay, I'll give you that.
All right, how much time do I have left?
5 minutes.
5? Oh, God, I got to rush. All right, look, everybody repeat after me. Packet drops are good.
Packet drops are good.
Louder.
Packet drops are good.
Great. RFC 3168 ECN. Anybody know what that is? Raise your hands. You could enable that and not have to have a packet drop to do congestion control. It's one line of code. Turn it on. So anyway, flow queuing is there. I would love to see some user space VPNs actually adopt some of this technology that we get better. So I started the Cake MQ project. By the way, I meant to pass this out. Nobody seems to know what Cake is. If somebody would like to throw into the kitty, I figure it'll take about $100 grand worth of development to vastly. No, pass it out. Pass around hat because I can't convince any major corporations to throw anything in. So just pass it around. Oh, I was going to put some business cards in there too. Anyway, hopefully we're going to make cake better. I have 3 minutes left to rant. Here I spent 14 years dealing with the physics, how Ys and Wi-Fi worked with queuing and stuff like that. And the ISPs were like, we just sell plans. You want 40 megabits? You got 40 megabits. And so a whole bunch of middle box makers added stuff to make the internet better, doing QoE solutions. And it turned out, we finally found out that all of them adopted FQCODL and made it their secret sauce, and then didn't track the new research. And I concluded that getting stuff into embedded takes a decade. I am working all the way up to the Federal Communications Commission to try to make it possible to get stuff adopted quicker. And EPF is just another workaround. So I started a new thing called eBreak This is my plug. In a year, opt-in statistics, I have 300,000 people running cake the way and FQCODL the way we intended. And I would love to give my team, which includes Stephen Heminger and everyone that's worked on Bufferbloat, a big hand, including some new participants like Robert and Herbert. So please, trying to remove all the latency from the internet, thousands of people involved, please give us a hand. All right, I got 2 minutes left. I might have a song. In the presentation, there's all kinds of pictures of real traffic. But I want to make a really big point. Can you get the camera back on me? No? Whenever they're ready. There we go. Bandwidth is a lie. Honestly, guys, 99.99999% of the time when you're using the internet, all you have are itty-bitty little packets, keystrokes to Google, nothing. If you actually measure it, there's no bandwidth in use at all. And yet, we keep designing things. You need to be able to watch 4 Netflix streams at the same time, 1 with each eye, and 2 for your parents. So the thing that I care most, you can get back to my slides if you want, if I'm not done. So I got a whole bunch of bugs I could use some help fixing, which include legal bugs. And I have last thing is I have a problem. For the last 4 years, I've been working on an algorithm to speed up what's called TCP slow start. Anybody know what that is? Slow start? Same people again. You can Google for it. What if you have an idea that can speed up the internet for web traffic by 1 to 3%? On top of the several 100% you already have, 1 to 3% for everybody. You've worked on it for 4 years. It's 56 lines of code. Do you patent it? Do you try to give it away? Do you go after VCs? I don't know, and I am talking about it any more than just what I said. I've been hinted significantly about it, but I can make lives, that much, a little bit much better if, by some other technique than passing the hat, I could find more support for the Bufferbloat project. So, anyway, thank you all for listening to me rant today. I'm doing a song tomorrow called the Mushroom Management Song. I hope you all learn the lyrics before then.
Round of applause for Dave, please. Okay.